All right, we're gonna jump in and do a breakdown. This one I'm very excited about. It's pretty simple, so I want to show you the simple example first. If I hit world simulation on, you can see this bottle spins, um, and it slows down, and it feels pretty natural. We can try that again. World simulation on. There we go, and it's spinning, and it slows down. And so what I wanted to show you today is how we were able to implement this spin with random. And here's the Lake Simple spinning script. So first of all, I'm going to put this here. I'm going to scale it up a little bit bigger so we can see more of the script. The text is a little large on the screen, but I think if I just minus that, you guys will still be, well, actually, Control plus, there we go. All right, so let's run through this real quick. We've got our imports here on the top. You'll notice we're using the Vidyuu Overtime utility. You can find that in the asset library. Now, if you do pull an item out of the asset library, you will note that, at least last I checked, which there was an update today, so it might be fixed now, you have to leave the world and come back for that script to come with the asset. So just be sure to do that. So anyway, pull out that Overtime utility, and that's going to allow this to make it much, much easier to do overtime like spinning. And then we've got the definition, our class here. We have no properties. We have a couple variables here, the spin loop async ID, so we can stop the loop. We have the number of iterations in the loop. Here in pre-start, we can see that we're connecting the event for player enter world. This is just a temporary to allow me to start the spin when a player enters the world. I have an NPC off camera that does enter the world, which is what starts up the spin. Then we have player enter world, and then we set the iterations remaining to be 40 plus, so we have a default iterations of 40. Now the reason I chose that is because down here you'll see that we are running at 100 milliseconds on our loop, which means 40 equates to 4 seconds, as there's 1,000 milliseconds in a second. So 1,000 divided by 100 means there's 10 of these per second. 10 divided by, or 40 divided by 10 is 4. So you have 4 seconds by default as the minimum spin length. Then from that, we add a random value from 0 to 60, and that value is then used floor to remove any decimal places, so we get a whole number between 40 and 100, with 99 being the highest it can be. Now that we know the number of iterations, we can then clear any previous intervals to make sure that we don't have more than one of these running at any given time. We then call the spin loop async, we set the spin loop async ID by calling async set interval and calling the spin loop and passing in the player parameter. This was not actually used, so, but anyway, it was for something later. Then we have 100 milliseconds as the amount of time between each iteration. The spin loop is going to then say, if iterations remaining is greater than 0, subtract 1 iteration. The rotation degrees defaults to 179, but then we're going to subtract, and you'll notice here that we're using a ternary operator, so we have the Boolean value. It says iterations remaining is greater than 44. If it is greater than 44, we return 0, meaning we subtract nothing. If it is less than or equal to 44, we then take 45, subtract the number of iterations remaining, and multiply by 4, meaning we're subtracting 4 degrees for every iteration closer to 0, which makes the rotation degrees go down until it basically comes to a complete stop, at which point we then rotate to, using our overtime utility, we rotate self to the rotation. We get the current rotation of self and then multiply that rotation by a Euler, a quaternion from Euler. To create that Euler, we need a vector 3. We then provide 0. The rotation is along the y-axis, and then another 0, so x, y, z. And then the amount of time we want to take is 100 milliseconds. We notice here that else, if there are no iterations remaining, we clear the timeout, so we stop this async interval from running any further. And that's it. That's how this loop works. Pretty straightforward and simple. Let's see it one more time now that we've seen the code. And world simulation on. There it goes. 1, 2, 3, 4, 5, 6. Nice. Pretty neat. I want to show you one last demo. I hope that was cool. I hope that breakdown, make sure you go back and like pause it. Breakdowns are hard, but they're really cool because it shows you the code really quick. You don't have to like see it. You can really just go and say, oh, I need that line. Let me go try that on my script. There's one other thing I need to make sure to remind you. Let me do that real quick before we see one last demo. Okay, so if you click on this bottle, you'll notice that the bottle's orientation has the Y pointing in a completely like 45 off angle, so it's not aligned. So what I had to do to get this to spin correctly was create a parent object and then rotate the bottle inside of that. I want to demonstrate that for you really quickly because I think it is so important, and as scripters, this is something we have to learn how to do to make our lives easier. So let me go find this spin bottle, the original. Let's see. Slumber Party, Assets, and spin bottle. All right. So here is our spin bottle. Thank you, Galactic, for making this so much nicer than and exactly what we needed. It's so good. There's the demo. We'll come back to that in a second. So don't worry, I promise. Okay, so now we need to get this to rotate. Now we could have just used the RGB RGB coordinates to X, Y, Z. So we could have just rotated this along the Z axis, so the forward, and rotating this, say, 90 degrees. You can see we could have totally just rotated it like that. But it's going to be a lot easier in our brains to think about it aligned with the worlds up, which is on the Y value. So right click, create parent object. This parent object is not rotated to facing up yet. So what I did is I went and took the rotation tool, I snapped it to 90 degrees, turned snapping on, then rotated this 90 degrees this way. And if I turn off rotation, oh wait, I just remembered, Control Z. I then took this bottle out of the group, come on, out of all groups, there we go. So the bottle is now out of the group, then I rotated it, so that way the bottle stayed flat. Then we can switch back to the move tool to see that the up is now aligned with the up, but I still want it to be more perfectly aligned on the forward as well. So I set this to 45 degrees, and then I switch back to the rotation tool and go 1, 2, 3. And if I switch back here, you can see that the blue is now pointing in the same direction as the bottle. This is important if you need to know the facing direction of the bottle. So the forward is facing forward and the up is facing up. We can then move the spin bottle back into this group and name it spinning bottle. And now that, if I attach the script, I should have shown you with it not attached. Simple spin script is attached, and go ahead and hit world simulation on. So there you go. So now it's working. Beautiful. Let's see. The next thing I wanted to show you was that if I remove the bottle from the group, delete this, come on, get you out of there, and then we attach the script to this bottle directly, you'll see that it spins on the wrong axes. Simple spin and start. There it goes. There is definitely a place for that sort of animation, just not in this case. All right, so the last thing I'm going to show you is we are building a kissing game. You know, the classic spin the bottle. I know. But like, I was always upset that spin the bottle wasn't like a proper spin the bottle, okay? Like, I don't like shooting games. This is gonna be, I hope, hopefully super socially uncomfortable. And so I've got my 3 NPCs set up here, and I took that spin the bottle mechanic and built upon it until we had this one, where it's going to choose one of these 3 random players, and it chose Joe. And the way that we did this, I'm going to describe it to you because it's really hard. We'll go ahead and run it one more time. It's kind of, maybe I should hit the reset button so the NPCs don't have to respawn every time. And it goes and it goes and it goes and it hits Joe again. Let's hit the reset button. Joe might be loading in just slightly a hair earlier. No, that couldn't be right. Okay, it definitely selected random people last time I tried this. Joe 3 times in a row isn't impossible, by the way. Random numbers, there we go. Bo, and we do it one more time. Random numbers often do that, where you get like heads, and you're like, that should be impossible, but like it does happen. And now we're back to Joe. Okay, whatever. So I don't want to show you the script because this is a challenge. If you want to try and implement it on your own, I'm going to at least tell you how it was done. So what we do is we check within a given radius of the bottle who is nearby. So we get world players and then check the distance to all the players in the world. And if they're within a range, those are our players that we want to have in the game. We then select one of those players at random. I have an array utility for this, arrayutils.getRandomItem. I didn't do that this time though, because what we did actually was even better than that. And you could totally do that with what I'm about to describe, but what we did was even better. We actually calculated the ending rotation by taking So that math that you see happening where it runs through, well, we did that math. So this is an intern and I were working on this. Napster. Napster's awesome. You'll see his work very soon. And so we calculated the rotation. So we knew it was 179 degrees for the first so many iterations, and then we knew that it slowly counted down. So we figured out where the end rotation was. And then once we knew where the end rotation was, we could then select whoever was most closely aligned with that end rotation. So we were checking to see who was there or closest to that position, including if there's only one person, it would select the person behind. So like it really does the math right. Then once we've selected the person who's most closely aligned, we then needed to spin and end on that person rather than ending where it was going to previously end. To do that, we're using I don't think we're using arraycast, we're using dot product to check alignment. If you're not familiar with dot product, if you dot two normalized vectors, this is some crazy math. If you dot two normalized vectors, it returns 1 if they're parallel, and -1 if they're anti-parallel, and if they're perpendicular, it's 0. And then at an angle, it's 45. If they're closely aligned, it's above 0.9. So we were checking for values above 0.98. And as soon as we were aligned with our target player at 0.98, we just stopped the rotation there. Now, this did have the problem that it would just continue spinning if the player was passed. So we had to actually reduce the iterations and start checking early. That is a very rough summary of what took us a couple hours to get implemented. If you want to try that out, that should give you some good direction. It's fun. It was a fun one to build. And I hope if you come and play our game when we launch it in a month, you feel super socially uncomfortable playing, because that's definitely the goal of that one. Anyway, so that is one of a few TV games I plan to implement. There's another one that I want to make a tutorial. It's a custom UI one with like multiplayer ideally. I want to make a multiplayer TV video game. You'll see a tutorial on it. It'll be fun. All right, I gotta go record one more tutorial before my meetings get started, so I will catch you later. Bye!